Hello, good day. How are you today? You're good, right? Okay. Are you ready for today's lesson? You are? That is good. So today in mathematics, we are going to be looking at differentiation of algebraic. Okay? Our topic for today in mathematics is on differentiation of algebraic. So are we ready for the lesson? Well, with our books and our pencils or pen to get into today's lesson, right? So what do we mean by differentiation? Differentiation in mathematics refers to the process of finding the derivative of a function, which represents the rate at which the function changes with respect to its independent variable. Okay? The derived function or derivative provides information about the slope of the original function at any point. Okay? Differentiation is the change of variable over another variables. Okay, do you understand? Then the derived function, or simply the derivative, is the result of the differentiation process. It provides information about how the original function behaves at a given point, okay? So in today's lesson, we're going to be looking at differentiation from the first principle. This is a method of finding derivatives using the limits definition of a derivative. The differentiation from the first principles involves using the limit definition of the derivative, okay? So let's say we have an algebraic equation like this, y is equals to x squared. Now using first principle for this function, you add changing y to y and also add changing x to x, okay? This is the symbol we use to identify change, okay? So we have here y plus change in y equals to bracket x plus change in x squared. Remember what I said? Using the first principle method, first you add change in y to y and add change in x to x, okay? When you have done that, you simplify further, okay? So you have y is equals to change in y, which is equals to, now this is raised to power 2, so it means this is in two places, okay? So we have x plus change in x, bracket open bracket close, and x plus change in x, bracket open bracket close, okay? So we have simplified this. Now we go further again to multiply, opening this bracket. So we have y is equals to change in y, which is equals to x times this x will give you x squared. X times the change in x is going to give you x change in x, okay? Plus, we move over to this one. Change in x times x is going to give you x change in x, okay? Plus, change in x times change in x is going to give you change in x squared. When we are done opening this bracket, we simplify further. Here we have x change in x plus x change in x. They are like terms, right? So we add them, it's going to give you 2x change in x, okay? So we have y plus change in y is equals to x squared plus this 2, which is 2x change in x plus change in x squared. Next, we're going to be moving y over this way, okay? So here we have plus y, so we're going to be moving it over this way. So the change of y is equals to x squared plus 2x the change of x plus the change of x squared minus y. Remember, y is positive here, so when coming over this way, it changes to negative. So we have minus y. But y is equals to x squared. So we're going to be replacing y with x squared, okay? So the change of y is equals to x squared plus 2x the change of x plus the change of x squared minus x squared. Now we have x squared here and x squared. So x squared cancel x squared. We are left with 2x the change of x plus the change of x squared, okay? So y, the change of x is equals to 2x, the change of x, plus the change of x squared. Do you understand how we got to this point? Now we're going to be dividing both sides by the change of x, okay? We divide this side by the change of x and also this side by the change of x. We are dividing each term by the change of x, okay? So the change of y over the change of x will be equals to 2x, the change of x, over the change of x, plus the change of x squared over the change of x, okay? Now we cancel. The change of x cancel this change of x. The change of x cancel this change of x. Now this is raised to power 2. So if this one cancel this one, there's still remainder of 1, right? So we have 2x plus the change of x. Now we are going to take the change of x to the limit 0, okay? We are going to limit the change of x to 0. So the change of y over the change of x will be equals to 2x plus, where you see the change of x, you put 0, so plus 0. So 2x plus 0 is going to give us 2x. So the change of y over the change of x will give you 2x, okay? Do you understand? So this is how to use the first principle method, okay? When you use the general method, you will also arrive at this answer. Do you understand? So when using the first principle method, you add the change of y to y and the change of x to x, okay? Then from there, you keep on simplifying till you get to this point. Do you understand? Now we are going to be looking at an example using this method we just used. So here we have y is equals to 3x squared. Here, x is raised to power 2, right? So we are going to be adding the change of y to y and the change of x to x. Remember how we did it. So y plus the change of y is equals to 3 bracket x plus the change of x raised to power 2. Here, x is raised to power 2, okay? Do you understand? So we simplify further. Y plus the change of y is equals to 3 bracket x plus the change of x bracket x plus the change of x. Okay? We go further again. Y plus the change of y is equals to 3. X times x will give you x squared. X times the change of x will give you x, the change of x, plus the change of x times x is going to give you x, the change of x, plus the change of x times the change of x is going to give you the change of x squared. What do we do next? We simplify further, which is equals to 3 bracket x squared plus x the change of x plus x the change of x, which is like them. We add it together, we have 2x the change of x plus the change of x squared. So we use 3 to open the brackets, okay? So we have y plus the change of y is equals to 3 times x squared is going to give you 3x squared plus 3 times 2x the change of x is going to give you 6x the change of x, okay? 3 times 2 will give you 6, okay? X the change of x plus 3 times the change of x squared is going to give you 3 the change of x squared. Do you understand? Now we move y over this way, okay? So we have the change of y is equals to 3x squared plus 6x the change of x plus 3 the change of x squared minus y. But y is equals to 3x squared. So we impute 3x squared in replacement of y, okay? So the change of y is equals to 3x squared plus 6x the change of x plus 3 the change of x squared minus 3x squared. Okay, hope you're not confused. So 3x squared cancel 3x squared over here. So we are left with 6x the change of x plus 3 the change of x squared, okay? So the change of y is equals to 6x the change of x plus 3 the change of x squared. Now what do we do next? We divide both sides by the change of x, okay? So the change of y over the change of x is equals to 6x the change of x over the change of x plus 3 the change of x squared over the change of x. We cancel. The change of x cancel this change of x. We're left here with 6x. Then the change of x here cancel this one. This one is raised to power 2, so we still have 1, the change of x left. So the change of y over the change of x is equals to 6x plus 3, the change of x, okay? So next we take the change of x to the limit 0. So the change of y over the change of x is equals to 6x plus 3. Anywhere we see the change of x, we put 0, okay? So bracket 0. 3 times 0 is going to give us 0, right? So the change of y over the change of x is equals to 3x plus 0. Remember, 3 times 0 is 0. 3x plus 0 is 6, right? Sorry, 6x plus 0 is 6. So the change of y over the change of x is equals to 6x. Okay? So this is the idea of the first principle method, okay? Do you understand? Good. I'm sure by now we're going to be able to use the first principle method, right? So differentiation involves finding the derivative of a function to understand how it changes locally. And the derived function, which is the derivative, gives information about the rate of change or slope of the original function. So this concept is fundamental in calculus and has application in various fields of physics, engineering, and economics, okay? If we were to use the general method, solving this will also arrive at this answer, okay? The general method is the power over here times the constant here, okay? So 2 times 3 is going to give you 6x raised to power 2 minus 1. The raised to power 2 will be minus by 1, okay? So 2 minus 1 is 1, so x is raised to power 1, so we have 6x. You see that we arrived at the same answer. So using the general method, you still arrive at this answer. Using the first principle method, you arrive at this answer, okay? Just that in the first principle method, you add the change of y to y and add the change of x to x. Okay? So you understood today's lesson on differentiation of algebra, right? So I'm sure we're going to be able to do our assignment. It's easy, right? Just follow the steps we did and you arrive at your answer, okay? Good.